In this video, we're going to go over section 2.1, basic functions and their graphs. So we're going to be talking about domain, evaluated function, a lot of different things. So let's first of all, let's figure out what we're looking at. So every set of, I'm just going to read this, relations. If there is any correspondence between two sets of information, it's called a relation. So if there's ordered pairs, everything is called a relation. From there, we can call it the special name of a function. And in a relation, the first number or component is called the domain or input, and the second one is called the range. So these right here are called relations. And then from here, we want to be able to decide if we can call them a function. So any set of ordered pairs is a relation. Okay, they're all called relations. Then we want to know from a special name is if we can call them a function. So it's kind of like detailing them more, putting them in a group, separating them. So a relation is in which each member of the domain corresponds exactly to one member of the range. So in other words, in this case, these are the actors and actresses and their pay. So here we've got this first one is a function because each actor or actress gets one pay. Now you say, well, but down here they're getting the same pay. That's okay for each domain as long as they have one answer, okay, or one number. If you look over here in this, if we reverse it and do the pay versus the range, if you notice here for 26, our input or our X value has two answers. So this would be considered not a function. All right, so a good way, it says, here's a definition of a function for you. A function is a correspondence from a first set called the domain to a second set called the range, such that each element in the domain corresponds exactly to one element in the range. So X, when you input it, can only have one answer. So let's look at these. So if I was to take this one, and sometimes this is hard, I could draw arrows. So I could put this in there and I could do 1, 2, 3, 4, and you don't have to draw the circles. I like to draw, or the ovals. So 1 goes to 6, 2 goes to 6, 3 goes to 8, and 4 goes to 9. So each one of my, this is my X, this is my Y, this is my domain, this is my range. For each one of my X's, it has only one answer. Some of them might be the same, but that's okay. So this is a function. Here, if I look at this, when I put my 6 here, all right, 6 has the answer of 1, but then 6 also has an answer of, 6 has the answer of 2. So 6 has two answers. Well, that is not a function. Right? It says here a function can have two different first components with the same different. So right here, sometimes you might have heard it said if there's a repeating X, it's not a function. All right, moving on. So this next page talks a lot about expressing functions, independent, some more vocabulary. All right. So the highlight here is, here we have, this is called an equation because it is a y equals. We've got some verbiage here where it says the variable y is a function of a variable x. For each value of x, there is one and only one value of y. Okay, so same thing for being able to call it a function. The variable x is also called the independent variable. The y variable is called dependent. So what they want us to do here is they want us to learn is function notation. So there's a special, if it's a function, we're going to use this special notation where this reads f of x, or sometimes it's f at x, represents the values of the function. So for our first one, we're talking about evaluating. So to evaluate a function, so in other words, that tells us that if for a function is that when I input my x value, I'm only going to get one answer. So because it's a function, I can put it in this notation. Before I know, I could also put this as an equation to look like that. But because I know it's a function, I'm going to use, instead of y, I'm going to use this f of x. So what I want to do is I want to evaluate this equation or this function, what happens when x is equal to 1. So instead of having to write all this out, this x equals 1, I can replace the x with a 1 right here. And that notation tells me, hey, wherever the x is, put a 1 in there. And then I just find and simplify the answer. All right. So let's say we have graphs and we want to know if the graph is a function. So there's something that's called a vertical line test that says if any vertical line intersects the graph in more than one point, then the graph does not define as a function. So in other words, if I had something that looks like this, if I had alright, and this is x, this is y, this is x. Alright, if I was to draw a vertical line, notice that my vertical line touches this graph in two places. What that tells me is for this x value, I have two answers, two y values. So this would be considered not a function. I couldn't call this graph a function. If I had something that looked like this, and you have to pretend that you're putting like vertical lines all along this. So what you could do also is you could take, I'm going to go back to here, you could take a piece of paper, and if it touches your paper in two spots, then it's not a function. So here, if I did this and I followed this, my graph is only touching this edge once. So this is considered a function. And we could draw more, and if you need some more examples, you could look up some more examples and to draw to help you out. So the next thing we're going to do is we're going to look at graphs, and we're going to find some how to write domain and range. So this says down here some information is about closed dots and open dots and some arrows. So we're going to work on a closed dot means that it can equal that number, an open dot means that it cannot, and arrows means that it extends to infinity. All right, and this information is also in your textbook, but I'm going to move on so we can practice some of this. I'm going to let you read that. You can always stop the video and read. All right, we're going to identify domain and range. Domain is our x values, and our range is our y values. All right, we're going to use interval, what's called interval notation, and we're going to use brackets, and we're going to use parentheses. Brackets mean that they can equal, okay, it can equal that number. Parentheses means that it cannot. So here we have closed dots, so we're going to be using brackets. So our domain is our x. So we know to know where our x values are. Well, our x values here start at -2, and it's a closed, so this is filled in, it's closed. So this is going to be -2, then I do a comma, and I look to where my graph ends, which is at 1. And that is my domain. To find my range, I'm going to find my lowest point. So here's where it touches the y-axis. I'm going to find my lowest point of my graph. And because there's a dot there, this is going to be 0, and I'm following the y-axis. So I'm going up to see where my highest point is on my graph, and it's right there, which is a 3. And I'm going to close that circle. Oh, there we go. So if we go to B, notice we have an open circle, so that's going to be a parentheses, but I have a closed circle where it's filled in, so this is going to be a bracket. So this is, I'm going to go on my range, I'm going to look here, okay, where it's going to touch my lowest spot, where it's going to touch the x-axis. There's my x-axis, which is at -3, and because it's an open circle, I'm going to use a parentheses. And then I'm going to follow it all the way. I'm going to follow on my x-axis. Where does my graph end? It ends here at the 2. So I'm going to do a 2, but my 2 is a closed circle, so I'm going to use a bracket. For my range, I'm going to go along the y-axis, and I'm going to go, what's my lowest point, which is right here, which is a 1. I'm going to use a parentheses because this is at that open. It's kind of hard right now to look at, but that's an open dot circle, and I'm going to move, and how high does it go? So here's my y-axis. I'm going to go, and it just goes to 2. So this would be comma 2, and close the bracket. All right, let's try some more here. Well, I'm going to let you stop the video and try this one because it has a closed and an open. So go ahead and stop the video, see if you can do it, and then I'm going to write in the answers here. So you should have gotten -2 and then 1 with the parentheses because that's an open dot. And then for your range, you would get, because of this down here, this dot, this would be a 1, and it's a closed, and this is going to go all the way up to 5, and that's a closed dot, so it's going to be brackets. All right, what if we don't have something that starts and stops in a spot, but we have something that keeps going? So this time we're going to be using our infinity. So for the domain, and you always start, when you do domain and range, you always start with the smallest. So because this is going off to infinity, again, I'm looking at the x-axis, this is going to go all the way to -infinity. So parentheses, I'm going to use -infinity, comma, and I'm going to come up here following the x-axis. I still have my graph, and oh, here's where it stops. At a 4, and because it's shaded in, it's a closed dot, I'm going to use a bracket. So now I'm going to follow along my y-axis, and here's the bottom of my graph, which is a 0. So I'm going to go 0, and then this is going to keep going. So my y's are still going as this is going to an infinity. So this is going to be going all the way. And this is hard because you're like, well, it's going to negative. Now remember, it's going -infinity for the x's, but for the y's, it's going to keep going, higher and higher. So this is going to +infinity because remember, we're following the y-axis for those numbers. All right, so that's domain and range, and that's interval. Okay, so this is interval notation. Now, one thing that might you might see is like on a number line. I'm just going to give you a quick example here so you can see that. Let's say on a number line you had 5 here and it was all shaded in. So let's say this is like X's, and let's do an open circle. Let's color it in. A closed. Let's do a closed. So we're going to say X is greater than or equal to 5. That's what this is what the graph would look like. Well, if I asked you to put it in interval notation, what you would do is you would have your starting point, which is 5, which is your closed circle, so I'm using a bracket, comma, and then I'm continuing on to positive infinity. So you can also do it for just number lines. Here we followed we followed the x-axis and then we followed the y-axis. But if I'm given an inequality, I can just write this 1, on a number line and then do an interval notation. Just kind of a side note. All right, let's see. What are we going to do next? Intercepts. So these are fun because intercepts are at what point do they cross the x-axis? All right, so x-intercepts, what are the points that cross at the x-axis? Y, where they cross at the y-axis. All right, let's see if we can't do some vocabulary in here. It says fill in the blanks so that the resulting is true. It says any set of ordered pair is called a relation. Every one of them. The set of the first components of the ordered pair is called the domain. So if you wanted to, you could have turned the video off and tried to fill this in. The second one is called the range. Okay. The shaded set of numbers shown on the x-axis in this graph can be expressed in interval notation as, so if we start here, this would be, there's a closed circle, so this would be closed at 0 and it goes all the way to 3 and it's an open circle, so it'd be a parentheses. This set represents the functions, and because it's on the x-axis, this would be the domain. All right, so maybe you could stop your video and see if you could do number 3 and fill in the blanks. All right. Sorry, I was waiting for you and you've clicked it off. So it says here the shaded set of numbers shown on the y-axis below can be expressed. And this one has an arrow. So this is closed. So again, we're looking at the y-axis because we're just doing the range here. So this would be a closed at 1. And because this is going off to infinity because of the arrow, we would infinity and then parentheses, and this is called the range. All right, so I'm going to let you, for these first 2, I'm going to let you stop the video and see if you can see whether these are a function or not. So number 1 is a function, and number 2 is not a function, because we have 1 has 2 answers, so actually 3 answers. Okay. All right, so now it says for practice, let's determine whether each equation defines a y as a function of x. Now remember, y can only have x can only have one answer. So here, if we were to solve this for y equals, this would be y is equal to negative x plus 16 if we move the x to the other side. Well, if I put in 1 x here, I'm only going to get 1 y. So this is, yes, this yes, this is a function. Yes, it defines it. Yes, it defines y as a function of x. Okay. This right here, if we were to solve, we would go y squared is equal to negative x squared plus 1, and we just needed y. So then we would take the square root, and whenever we take a square root, we have to take both the positive case and the negative case. So this, what this is telling us is when we put our x in here, we're going to end up with two answers. We're going to end up with a positive and a negative. So this one is a no. This is not a function. Okay? This does not define y as a function of x. All right, and you could look at the graph too. That's the nice thing about technology, is when you solve for x, or you could use Desmos, you could put this in there. So if you pretend, you can also pretend that this is, you don't have technology, but you could check your work. All right, and this right here, this is yes, because this only has, again, this is 1x, 1y, so yes. All right, yes, this defines the, yes, y is, oh my, two is y is a function of x. All right, moving on. All right, so let's evaluate these. Okay, where we had that in the very beginning. So how this reads is we've got g of x is equal to x squared plus 2x plus 3. So the first thing we're going to do is we're going to allow x to be a negative 1. So we're going to go g of negative 1 is equal to, now we got to be careful, wherever there's an x, I like to tell my students put a parenthesis. So go negative 1 squared plus 2 times negative 1 plus 3. Well, negative 1 times negative 1 is 1, plus 2 times negative 1 is negative 2, plus 3. So if we put this in, 3 plus 1 is 4, plus negative 2 gives us a 2. So if we input a negative 1 into our graph, our output or our y value is going to be 2. All right, so B, so that was A. So B, g of x, they want us to put in x plus 5. So what that is we're going to go x plus 5 squared, because it says whatever your input is, you're going to square it. And our input this time is x plus 5. This is our whole input. And now we're going to go plus 2 times x plus 5, and then plus 3. So this is going to be x plus 5 times x plus 5. And then we're going to distribute, so 2x plus 10 plus 5. So we have to multiply this and multiply this. Here we need to FOIL. So this would be x squared plus 10x plus 25 plus 2x. And I'm going to go ahead and add these two, plus 15. Put like put like terms together. So we would have x squared plus, let's see, we would have 10 and 2, so that's 12x, and then 25 and 15. Oh, how did I get a 5 there? Oh, I took a 5 to a, how about I change this to a 3, not sure how I got a 5 there. And we change this, whoops, if you can see here, sorry, to 13. So 25 plus 13 is 38. So if we were to input x plus 5 into it, we would get this expression, and that's perfectly fine. You can end up with an expression. That is not a problem because we started with an expression. Here we started with a number, we got a number. Here we started with an expression and we just got a bigger expression. All right, let's do C. So C is g of negative x. So again, I'm going to put in parentheses. I'm going to go get some more lead. Here we go. Sorry about that. All right, we're going to put in negative x, and we're going to square it. Plus 2 times negative x plus 3. Well, negative x times negative x gives us an x squared. 2 times negative x gives us a negative 2x. And then plus 3. And we don't have any like terms put together, so we're done. That's our answer. Okay. Number 7, we have f of r. You're like, well, that's not an x. Sometimes they use different letters, but notice that there's an r here. So this is f of r is equal to the square root of r plus 6, and then the plus 3 is on the outside. So why don't you stop the video and see if you can do these. All right, well, welcome back. So for A on this one, you should have gotten that f of negative 6 is equal to 3. Part B, you should have gotten when you input f in 10, you should gotten 7. And then for C, you should have gotten for f of x minus 6, you should have gotten the square root of x plus 3. If you did not, you can ask me in class. All right, moving on. Our next page. It says to look at these and see if these are a function or not. So why don't you stop the video, use the vertical line test, and see if these are a function or not. Graph of a function or not. Function. Whoops. 8 is a function. 9 is not. And 10 is a function. All right. If you need help with that, ask me in class. All right, here we go. Number 11. So now we're going to use a graph to evaluate to find the following. It says, for the following, for what value of x is g of x of 1? So g of x equals 1. So what that means is this is the y value. So we've got to figure out what is the x value. Because remember, g of x is the same as y is equal to 1. So we got to figure out what x is. So we come over here and we're like, okay, here's the y-axis. Here's 1. So we come over here and right there is y is 1. So what is x? X is negative 2. So x is equal to negative 2. And if you notice, this is the point negative 2, 1, which is right there, y and x. This one says find g of x. So if x is 2, what is y? So if I input a 2 here, what is my y value down here? When I come over here, this is negative 2. All right? Why don't you stop the video and see if you can't do number 12. So if you look at, this is x. If x is negative 4, what is y? Come over here. So x is negative 4. You come over here and it looks like it would be negative 5. It says for what value of x is f of x equals to negative 3. So this is if y is negative 3, it looks like x is going to equal -2. Okay, sorry about that. The last thing is it wants us to find is the domain, the range, and write the x-intercepts and the y-intercepts. So for this one, where you have the domain, so my x values, all right? So for my x values, looks like I can use everything. I've got arrows on both sides. I've got arrow going towards positive infinity and an arrow going to negative. So this is going to be -infinity to infinity. My range, though, is going to be different because I look along the y-axis, and my y is going to start at 1 and go all the way to positive infinity. So for C, my x-intercepts, I don't see any. So, oops, sorry about that. There are none. And then D, for my y-intercepts, there's my y-intercept where it crosses, x is 0, and y is 1. All right, why don't you stop the video and try on this one to do the domain and range. Well, welcome back. The domain on this one for the x's is going to be 0 to 5, because it stops right here on the x-axis. For my range, I'm going to come down here, go -1, and I'm going to go all the way up to 5, and that's an open circle, so that's going to be a parentheses. Is there any x-intercepts? There's one right here. I'm going to call that a 2, so I'm going to go 2, 0. And then for the y-intercept right here, it's crossing the y-axis, so that's 0, -1. All right, and I believe that's the end of it. I'll put that right there. All right, you guys, thank you, and if you have any questions, ask me in class.